doesn't move much after that. It bounces around real slowly. And slowly with time, all those air molecules up here, well, they work their way down. They're going to bounce back and forth all over the place. So eventually they all get down there and see the cold stuff. And I've got a pair of tongs around here someplace. You do not want to dip your fingers in the nitrogen. Okay. And I can freeze the balloon too. There we go. See how this is stiff? Okay, now as it warms up, you won't even be able to see it get closer, so there's some liquid in here. I've liquefied the oxygen and some of the nitrogen. It occupies a whole lot less volume now. Now as it warms up, it should reinflate this whole balloon. Just takes a while. It's very cold. There's liquid down the bottom of it, and it's real thin. How about that? That'll go good. That'll get going faster. Dump the liquid down here where the balloon's hot. Oh yeah. Anyway, good as new. If you take it nice and slow, it's as good as new. Okay. I'm going to pour some in here. Oh, I wanted to freeze a balloon too. Okay, here's a balloon we didn't blow up. This is another one of those animal balloons. I'm just going to let him go swim. Push him down. I mean, the problem with these doers is you can't show you what's in there. So I'm going to pour some in here and let it boil away. It looks just like water. Okay, here's a balloon that has been reduced from room temperature. Fun stuff. Now I'm going to pour some nitrogen in there, then I'm going to cap it off. Let's see if I can pour it in there. This is not designed to pour. This is a bad idea. And you spill a lot. Got about a half an inch in there. Wasting a lot of nitrogen. Goes running across the table. When I'm done, I'm going to dump the rest of what I've got on the floor and let you watch it. Chase it around the room. Okay, I'm going to catch the air. Okay. So that's nitrogen gas in there, and it's turning into literally air. So it's taking up a lot more volume. A liter of the liquid takes up 22.4 liters as a gas. And as the liquid boils away, it turns into a gas and will inflate the balloon. 22.4 liters. That's about 5 gallons, 6 gallons. This balloon's going to get very large. Now, it's going to get there slowly because it's warming up. Okay. See, the liquid nitrogen here is in this thin plastic bottle resting on a hot countertop. And I can warm it up a little bit. It is important that you not put your hand down on the liquid nitrogen. Not for any substantial period of time anyway, because your hand gets real cold real fast. I'm not just kidding. Deadly serious. Okay, I'm going to help things along a little bit. I'm going to dump some nitrogen in there. And dump it back. Really sincerely cold. Okay, and it's continuing to grow. Now look at this. That's the balloon. It was much smaller than this originally, but it's stayed great big. And if you look at it, it's beginning to shrink. As it warms up, it's becoming elastic again, and it's shrinking down. See, it was great big. It was a couple of square feet. And as it warms up, it's going to be a little bitty balloon again. I was prepared to put it out of its misery. Okay. You don't want to get that on your hand. That wasn't enough of it. You don't want to get that on your hand. Can you see it run across there a little bit? It looks just like water running downhill. You saw me put it in the bottle. You can see it boiling. Okay. Now, another material, the reason these guys react is it's rubber. It's plastic, actually, which makes it a long hydrocarbon chain. So think of it like a spaghetti strand. It's a backbone of carbon, 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 decorated with hydrogens. It makes a strand. You make a bunch of them, and you kind of layer them together, and they're very flexible. You know, they're all over the place. Well, you freeze them down. It's like taking that spaghetti, cook spaghetti and freezing it. And then you start bending it. It breaks. There's just no choices there. Okay. Now, I've got 2 racquetballs here that have been cooling for a little while. They don't sound quite like a racquetball should, right? No. Shatters like a piece of glass that the cat got into a Christmas tree. And of course, it went behind here. Now, I've got one more in here that I'm going to hurl at the wall. This stuff is very cold, so you don't want to hold it. You can handle it like a baked potato, like a hot potato. Very nice, huh?
All right.
Like it's telling me I gotta buy
After it
it.
warms up, it's a rubber ball again. It just happens to be in 2 million pieces.
I don't know how big of a video file this is going to be, but it's fine. I can put it somewhere and send it to you. Can I get your number or email or something?
I'll give it to you in a second.
All right.
I wish I could say that we actually bothered to send them back and tell them, this is wallet broke. Okay. Now the last thing I'm going to do, I'm going to dump this nitrogen out on the floor. Now you can't see it from where you are. So if you want to come up and look, come on down here. What's going on? Okay. Have you ever made pancakes? You get a skillet hot. How do you test to see if it's the right temperature? Put your hand on it. Bad idea. Come on, somebody's got to know. How do you test it? Yeah. You throw water on it. You throw your fingertips a little bit wet. You throw specks of water in there. If they hit the surface and just flash into the vapor, it's too hot. If they hit there and sit there and then boil away, it's too cold. But if you have the right temperature, it'll go and skitter around on the surface. What's happening is the water drop resting on the surface, it boils a layer of the water away, and it'll ride on that layer. That's what's happening with the nitrogen. I'm going to dump it on the floor. You'll see it. It'll go running around the floor, picking up dust. So come on down if you want to see it. Anybody that's got flip-flops on, this would be a bad idea. Shoes is no problem. Flip-flops, not so much. Okay.
You joined us. Make sure you don't block this camera.
Yo, let the camera out.
To be nice.
Okay. Here we go. This is the one-shot deal. That's all I got left. Okay. See, it goes running across the floor. It won't hurt your shoes. It won't hurt you. It's getting neat. See it go running around?
Yeah.
Not the best idea to go right in your shoe. Here's the last one. It goes running around there. So it's going all the way to the corners of the room out there. Probably all the way to the corner. Yeah, I can keep some moving around back
Look behind you.
You okay?
Yep, that ripped me. What happened?
I think my animal balloon died. Anyway, yeah, there's still a little bit advancing out here, slowly dying. That liquid just slowly evaporates. But see, it's in less thermal contact with the surface by riding on that layer of evaporating nitrogen. And it is remarkably cold. But see, even this thing is getting cold.